And the most astonishing part? Most people have never heard these stories, because extinction doesn't always come with a dramatic explosion. Sometimes, it almost happens silently, like a candle flickering in a dark room. Tonight we're going to explore one of the most fascinating scientific questions of all time. How close did humanity come to disappearing forever? And the answer may surprise you, because according to modern genetics, climate science, and archaeology, at one point in our ancient past, there may have been fewer than 1,300 humans left alive on Earth. That's fewer people than you might see at a small music concert. Fewer people than the population of a single village. All of humanity, balanced on a razor's edge. Pause for a moment and let that sink in. Every person you know, every civilization, every invention, every story, almost never happened. But how could that possibly be true? How could a species that now numbers over 8 billion people have once nearly vanished completely? The answer takes us back hundreds of thousands of years, to a world that looked very different from the one outside your window tonight. A colder world, a harsher world, a world that seemed almost designed to erase fragile species. And yet somehow, humans survived, but not without coming terrifyingly close to the edge. Let's begin with something scientists call a population bottleneck. It sounds technical, but the idea is actually very simple. Imagine a large jar filled with thousands of different colored marbles. Each marble represents a person, carrying unique genes, traits, and variations. Now imagine that jar suddenly being shaken, and almost all of the marbles fall out. Only a small handful remain. Those few marbles are now responsible for creating the entire future collection. That is a population bottleneck. And according to genetic research, humanity may have passed through one of the narrowest bottlenecks in the history of life. Scientists studying human DNA discovered something strange. Across billions of people on Earth, our genetic diversity is surprisingly low, much lower than many animal species. For example, chimpanzees, our closest living relatives, have far more genetic variation than humans do. That's odd, because humans occupy the entire planet, from the Arctic to tropical rainforests to deserts and megacities. You would expect huge diversity. But instead, our DNA tells a different story. A story suggesting that long ago, the human population shrank dramatically, as if nearly everyone disappeared, leaving only a small group of survivors. But when did this happen? And what could possibly cause such a catastrophic decline? The clues come from an unexpected source: volcanoes. Around 74,000 years ago, something enormous happened on the island of Sumatra. A supervolcano erupted. Today, that volcano is known as Toba. And when it exploded, it may have been the most powerful volcanic eruption in the last 2 million years. To understand the scale of this event, imagine this. The eruption blasted thousands of cubic kilometers of ash into the atmosphere. That's enough volcanic material to bury entire countries. Ash clouds spread across Asia, darkening skies thousands of kilometers away. Some scientists believe the eruption triggered what is known as a volcanic winter, a dramatic global cooling event. Sunlight blocked, temperatures dropping, ecosystems collapsing. If you've ever seen what a volcanic eruption does to a nearby town, imagine that effect, happening across half the planet. Forests dying, animals disappearing, food becoming scarce. For early humans, who depended entirely on nature for survival, this would have been devastating. Some researchers estimate that the human population may have dropped to just a few thousand individuals, possibly even fewer. A tiny group scattered across Africa, survivors of an environmental disaster unlike anything our species had ever faced. But here's where the story becomes even more intriguing. Not all scientists agree that Toba nearly wiped us out. Some archaeological sites show evidence that humans continued living in parts of Africa and India during this period, which raises a fascinating mystery. If the eruption was so catastrophic, how did humans survive at all? Were we simply lucky? Or did something about human intelligence, cooperation, and adaptability give us a unique advantage? That question opens the door to one of the most remarkable survival stories in the natural world. Because the truth is, the Toba eruption may not have been the only moment humanity stood on the edge of extinction. There were others: ice ages, droughts lasting thousands of years, massive climate swings that reshaped entire continents, events that forced our ancestors to migrate, adapt, or disappear. And yet, they endured. Not because they were the strongest animals on Earth, far from it. Early humans were physically weaker than many predators, slower than antelope, less powerful than bears. But we had something else, something far more dangerous: curiosity. The ability to learn, to share knowledge, to solve problems together, to imagine tools that didn't exist yet. Those simple abilities may have saved our species more than once. And in the next part of this story, we'll explore a discovery that shocked geneticists. Evidence suggesting that humanity may have come even closer to extinction than scientists once believed. A bottleneck so severe that for thousands of years, the entire human population may have been smaller than a modern airplane full of passengers. But before we continue this journey into our species' fragile past, here's a small thought to carry with you tonight. Every single human alive today is the descendant of survivors. People who endured ice ages, volcanoes, starvation, and unimaginable uncertainty. If that realization sparks your curiosity about the strange survival story of our species, you might enjoy staying with us for the rest of this quiet exploration. And if you ever feel like supporting the channel in a simple way, leaving a like, subscribing, or sharing your thoughts in the comments helps more people discover these stories of science whispered through time. Now, take a slow breath. Let your mind drift a little deeper into the past, because coming up next, we'll travel nearly 1 million years back in time, to a mysterious period scientists now call the Great Human Bottleneck, a moment when humanity may have been closer to extinction than we ever imagined, and the evidence was hidden inside our DNA all along. The story continues. Now, let's travel much further back in time. Not 70,000 years ago, not even 200,000 years ago, but nearly 1 million years into the past. A time when our species, Homo sapiens, did not yet exist. The Earth looked very different then. The continents were familiar, but the world was colder, harsher, and far less predictable. Massive glaciers expanded and retreated. Rainfall patterns shifted dramatically. Entire ecosystems rose and collapsed over thousands of years. And somewhere in this ancient, unstable world, our distant ancestors were struggling to survive. They were not yet modern humans. They were earlier members of the human family, creatures that walked upright, used primitive tools, and lived in small wandering groups across Africa. But something extraordinary happened during this period, a mystery hidden deep within our DNA. In recent years, scientists studying human genetics discovered evidence of what might be one of the most dramatic population collapses ever experienced by a species. Researchers noticed a strange pattern. When they analyzed the genomes of thousands of people across the world, they found signs of an extreme genetic bottleneck. Not just a small population decline, but something far more severe. According to some studies, around 900,000 years ago, the global population of our human ancestors may have dropped to only about 1,200 breeding individuals. Let that number settle for a moment. 1,200, not 1,200 million, not even 1,200,000. Just 1,200 individuals capable of passing their genes to the next generation. To visualize that, imagine a large airplane. A modern passenger jet can carry roughly 400 people. Now imagine 3 airplanes filled with passengers. That might represent the entire surviving human population on Earth at that time. Every ancestor, every future lineage, balanced on a tiny, fragile population. If those few groups had disappeared, human history would have ended before it even began. No cities, no science, no music, no stories. Just silence. What could possibly cause such a catastrophic collapse? The leading explanation points towards something slow, relentless, and planetary in scale: climate change. But not the kind we talk about today. This was something much larger. Around 1 million years ago, Earth entered a period scientists call the mid-Pleistocene transition. Before this transition, ice ages occurred roughly every 41,000 years. But after this shift, the rhythm of Earth's climate changed dramatically. Glacial cycles became much longer, around 100,000 years each. This meant colder periods lasted far longer than before. Glaciers grew larger. Droughts stretched across continents. Habitats shrank. For early human populations, this may have been devastating. Food sources disappeared. Migration routes collapsed. Small groups became isolated from one another. And when populations shrink, genetic diversity shrinks with them. Imagine again that jar of marbles. But this time, instead of spilling most of them suddenly, the jar slowly empties over thousands of years. One group disappears here, another fails to survive there, until eventually only a few scattered communities remain. This may have been what happened to our ancestors. And the most remarkable part? This bottleneck may have lasted over 100,000 years. That means for more than 100 millennia, human ancestors existed as a tiny population on the edge of extinction, generation after generation, living with constant uncertainty, surviving droughts, adapting to colder climates, searching for food in landscapes that change constantly. Yet somehow, they endured. Here's where the story becomes fascinating, because something unusual happened after this long bottleneck. Around 800,000 years ago, the human population slowly began to recover. And scientists suspect this recovery may be connected to one of the most important technological breakthroughs in human history. Fire. Yes, fire. It sounds simple, but controlling fire may have been one of the most powerful survival tools ever discovered. Think about what fire provides: warmth in freezing climates, light during long nights, protection from predators, and perhaps most importantly, cooked food. Cooking dramatically changes the way our bodies extract energy from food. Raw plants and meat require enormous digestive effort, but cooking breaks down fibers and proteins, making nutrients easier to absorb. In simple terms, cooking allows the body to gain more calories from the same food, and extra calories mean something extremely valuable for evolution. More energy for larger brains, more energy for survival, more energy for growing populations. Some scientists believe that the control of fire helped early humans expand into harsher environments, cold regions that were previously impossible to survive in. Fire may have allowed our ancestors to outlast climate extremes that wiped out many other species. In other words, technology may have saved humanity long before modern civilization existed. A simple flame, protecting a fragile species. But even after surviving the great bottleneck, our ancestors were not safe. Far from it. Over the next several 100,000 years, human populations would face repeated challenges: massive ice ages, severe droughts in Africa, volcanic disasters, and competition with other human species. Yes, other humans. Because long before modern civilization, Earth was home to several different kinds of humans. Some stronger, some adapted to colder climates, some with brains as large as ours. And at times, our ancestors shared the planet with them, which raises a fascinating question. If multiple human species existed, why are we the only ones left? What happened to the others? Did climate wipe them out? Did competition eliminate them? Or did something else occur? Something far stranger. Because in the next chapter of our story, we'll meet one of the most mysterious human relatives ever discovered. A species that survived in Ice Age Europe, built tools, hunted massive animals, and may have even created art. Yet today, they are gone, vanished from the earth, leaving only fragments of bones and traces of DNA hidden within modern humans. Their name is Neanderthal. And the story of what happened between them and us may reveal another moment when humanity stood dangerously close to extinction. But before we step into that frozen prehistoric world, take a quiet moment to reflect on something remarkable. Every person alive today carries DNA that passed through these ancient bottlenecks, through volcanic winters, through climate chaos, through population so small that a single unlucky century could have erased our lineage forever. And yet, the chain was never broken. Generation after generation, the thread continued. A fragile thread of survival stretching across nearly 1 million years. And tonight, you are part of that story. Now, let your mind drift a little deeper into the Ice Age. Because ahead of us lies one of the greatest mysteries of human evolution. A mystery involving another species of human who once walked the earth beside us, and whose disappearance may hold clues about how close our species came to vanishing too. The story continues. Now, imagine walking through a cold European forest 40,000 years ago. The air is sharp. Ice sheets cover much of the northern land. Huge animals move through the landscape. Woolly mammoths, giant deer with antlers as wide as doorways, and somewhere in the distance, a group of humans sits around a fire. But they are not quite like us. Their bodies are broader, their bones thicker, their faces more powerful, their noses larger, adapted to warm, freezing air before it reaches the lungs. They are intelligent, skilled hunters, masters of survival in one of the harshest environments on Earth. They are Neanderthals. For hundreds of thousands of years, Neanderthals thrived across Europe and Western Asia. They built tools, hunted large animals, used fire, and lived in complex social groups. In many ways, they were just as human as we are. And yet, today they are gone. For a long time, scientists believed Neanderthals disappeared because they were somehow primitive. Maybe they weren't smart enough. Maybe they couldn't compete with modern humans. But over the last few decades, that simple explanation has started to fall apart. Because the more we learn about Neanderthals, the more impressive they appear. Their brains were actually slightly larger than the average modern human brain. They created sophisticated stone tools. They cared for injured members of their group. Some archaeological sites even suggest they may have created symbolic objects, possibly early forms of art or decoration. In other words, they were not the clumsy cave creatures people once imagined. They were a highly capable human species, which makes their disappearance far more mysterious. Around 60,000 to 70,000 years ago, modern humans began migrating out of Africa. These early Homo sapiens spread slowly into the Middle East. then into Asia, and eventually into Europe. And when they arrived in Europe, they encountered Neanderthals, two different human species, sharing the same planet, sometimes the same landscapes, sometimes even the same caves. For several thousand years, they coexisted. And during that time, something unexpected happened. They had children together. Yes, modern humans and Neanderthals interbred. This is not speculation. It's written directly into our DNA. Today, most people outside Africa carry about 1 to 2% Neanderthal DNA, tiny fragments of genetic memory from a species that no longer exists. It means that somewhere in the distant past, a Neanderthal ancestor and a human ancestor met, and their families became connected. A quiet merging of lineages, a reminder that the boundary between human species was not always so clear. But eventually, something changed. Around 40,000 years ago, Neanderthals vanished from the fossil record. Their bones stopped appearing in archaeological sites. Their tools disappeared. Their campsites went silent. And the world was left with only one surviving human species: us. The question is, why? Why did Neanderthals disappear while Homo sapiens survived? Scientists have proposed many possibilities. Some believe climate change played a role. During this time, Europe experienced severe and rapid climate swings. Cold periods followed by warmer ones. Habitats shifting unpredictably. Animals migrating or disappearing. Small populations of Neanderthals may have struggled to adapt to these changes. Another theory involves population size. Modern humans may have had larger, more connected populations. Neanderthal groups were often small and isolated. And when populations become too small, they face dangerous genetic problems. Inbreeding increases. Genetic diversity shrinks. Diseases become more devastating. In such fragile populations, even a few difficult centuries could lead to extinction. There is also the possibility of competition. Modern humans may have had advantages in social networking, trade between distant groups, more advanced tools, or perhaps more flexible diets. Small advantages, multiplied over generations, can change the fate of species. But the truth is, we still don't fully know what happened. Extinction rarely has a single cause. It is often a combination of pressures, climate, disease, competition, random chance, all working together slowly until a species disappears. But here's something fascinating. Even though Neanderthals vanished, they were not completely erased. Their genes live on inside many humans today. Some of those genes influence our immune systems. Others affect how our bodies respond to cold climates. There are even studies suggesting that certain Neanderthal genes may influence sleep patterns, which is a curious thought for a sleep podcast like this one, because somewhere in your DNA, there may be a tiny fragment of genetic code from a human species that disappeared 40,000 years ago, a quiet echo of an ancient cousin. Now imagine how fragile the situation truly was. For tens of thousands of years, multiple human species shared the earth. But today, only one remains. If history had unfolded slightly differently, it might not be us telling the story. Perhaps Neanderthals would be the dominant humans today, building cities, launching spacecraft, recording quiet science podcasts about extinct Homo sapiens. It's a strange idea, but evolution is full of strange outcomes. Survival does not always go to the strongest or the smartest. Sometimes it simply goes to the species that adapts at the right moment. And yet, even after Neanderthals disappeared, humanity still faced enormous dangers, because the planet itself was about to enter one of the most extreme periods of climate instability in recent history. A time when ice sheets miles thick covered huge portions of the northern hemisphere. A time when sea levels dropped dramatically. A time when vast deserts expanded across continents. This was the last ice age. And for early humans, it created new survival challenges that pushed populations to the edge once again. Entire regions became uninhabitable. Migration routes shifted. Food sources vanished. Small groups of humans were forced to travel enormous distances just to survive. And some scientists believe that during this time, human populations may once again have fallen dangerously low. But something extraordinary also began happening during this harsh period. Something that would eventually change the fate of our species forever. Human imagination was awakening. Art, symbolism, language becoming richer, ideas spreading between groups. For the first time, humans were not just surviving the world, they were beginning to reshape it. And in the next part of our story, we'll explore a mysterious event that nearly erased humanity once again, a sudden climate shock so severe that it plunged parts of the world back into near glacial conditions in just a few decades. Scientists call it the Younger Dryas, a climate disaster that may have pushed early human civilizations dangerously close to collapse. And the cause of this sudden catastrophe remains one of the most debated mysteries in earth science. The story continues. Imagine living at the end of the Ice Age. For thousands of years, the world had been warming. Glaciers were slowly retreating. Vast frozen landscapes were transforming into forests and grasslands. Animals migrated into new territories. Rivers flowed again through valleys once locked in ice. In human communities, small bands of hunters and gatherers were beginning to experience something unusual: stability. For the first time in a very long time, the climate seemed predictable. Food became easier to find. Plants returned to regions that had been barren. Some human groups even began settling in the same places season after season. It was the beginning of something remarkable, the earliest seeds of civilization. But then, something unexpected happened. The warming suddenly stopped, almost overnight. The planet lurched back into cold conditions. Scientists call this mysterious period the Younger Dryas. It began roughly 12,900 years ago, and what makes it so extraordinary is how quickly it happened. In geological terms, climate usually changes slowly, thousands of years, sometimes tens of thousands. But during the Younger Dryas, temperatures in parts of the northern hemisphere dropped dramatically in just a few decades. Imagine waking up in a world that is steadily warming, only to see it suddenly plunge back into near glacial conditions within a single human lifetime. Winters becoming harsher, growing seasons shrinking, animals migrating again. For early human communities, this would have been deeply disruptive. Food sources changed, landscapes shifted, entire ecosystems reorganized themselves, and the stability people had begun to rely on vanished. One of the leading theories behind the Younger Dryas involves something enormous happening in North America. At the end of the last ice age, much of Canada and the northern United States were still covered by massive ice sheets. As these glaciers melted, they released enormous amounts of fresh water. Some scientists believe that at one point, a gigantic glacial lake suddenly drained into the North Atlantic Ocean. Imagine a flood of fresh water on a scale difficult to comprehend, an amount capable of altering the chemistry of the entire ocean. This sudden influx may have disrupted one of the most important climate systems on Earth, the Atlantic Meridional Overturning Circulation. You can think of it as a giant conveyor belt of ocean currents. Warm water travels north from the tropics. Cold water sinks and flows south again deep below the surface. This system helps regulate global climate. But if enough fresh water enters the North Atlantic, the circulation can slow down, or even temporarily stop. And when that happens, the northern hemisphere cools dramatically, almost like flipping a planetary thermostat. Evidence from ice cores drilled deep in Greenland shows that temperatures there dropped sharply during the Younger Dryas. In some regions, average temperatures may have fallen 5 to 10 degrees Celsius. That's a massive shift. For comparison, the difference between today's climate and the peak of the last ice age was roughly the same magnitude. Now imagine that kind of change occurring in just a few decades. To early human societies, this would have felt like the world suddenly turning hostile again. But here's where the story becomes even more intriguing. Some scientists believe the Younger Dryas may have done more than just challenge human survival. It may have actually accelerated the development of civilization. When environments become unpredictable, humans often innovate. For groups living in the Middle East, particularly in a region known as the Fertile Crescent, the colder and drier conditions may have pushed people to experiment with new ways of securing food. Instead of relying entirely on wild plants, they began intentionally cultivating certain species, early forms of agriculture, planting seeds, returning to the same fields, gradually learning which crops grew best. In other words, a climate crisis may have helped trigger one of the most important transformations in human history, the birth of farming. And from farming, everything else eventually followed. Permanent settlements, villages, cities, civilizations. It's a fascinating paradox. A sudden climate shock that may have threatened human survival, but also pushed our ancestors toward innovations that shaped the modern world. But the Younger Dryas still holds mysteries. Some researchers have proposed a much more dramatic explanation, a controversial idea known as the Younger Dryas impact hypothesis. According to this theory, a fragment of a comet or asteroid may have exploded in Earth's atmosphere around the same time. The explosion could have triggered massive wildfires across continents, injected dust into the atmosphere, and contributed to the sudden cooling. Evidence cited for this idea includes unusual microscopic particles found in sediments, materials that may form during high-energy impacts. However, many scientists remain skeptical. The evidence is debated, and the hypothesis continues to be studied. Whether the cause was glacial floods, cosmic impacts, or some combination of factors. The Younger Dryas remains one of the most dramatic climate shifts in recent Earth history. Eventually, after about 1,200 years, the cold period ended. Temperatures rose again, glaciers retreated once more, and the world entered the stable climate period known as the Holocene, the same climate era we still live in today. This stability allowed agriculture to spread, cities to rise, civilizations to grow. In many ways, modern human history only became possible because the climate stabilized after the Younger Dryas. But it also serves as a reminder. Earth's climate system is capable of sudden, dramatic change, and human survival is often dependent on the ability to adapt quickly. As you reflect on this quiet journey through deep time, consider how many times our species has stood near the edge. Volcanic winters, genetic bottlenecks, ice ages, climate shocks, encounters with other human species. At many points, the survival of humanity was far from guaranteed. History could have ended before it began. And yet, through creativity, cooperation, and adaptability, our ancestors endured. But our story with extinction risks does not end in ancient history. Because in the next chapter, we'll explore a much more recent threat, one that emerged not from volcanoes or glaciers, but from something invisible. Tiny organisms, capable of reshaping entire civilizations, diseases, pandemics, events that have repeatedly reduced human populations throughout history, and remind us how fragile even advanced societies can be. And some of these outbreaks came surprisingly close to changing the course of human history forever. The story continues. Imagine waking up tomorrow and discovering that humanity almost disappeared in the past. Not once, but several times. Volcanoes, ice ages, climate shifts that reshaped entire continents. But some of the most dangerous threats humanity has ever faced have been almost impossibly small. So small that for most of human history, we didn't even know they existed. Tiny organisms, invisible to the naked eye, yet capable of reshaping civilizations. These are pathogens, viruses, bacteria, microscopic forms of life that spread quietly from person to person. And throughout history, they have repeatedly reminded humanity of something unsettling, that even large, complex societies can be surprisingly fragile. Imagine a bustling medieval city, narrow streets, crowded markets, animals moving alongside people, food stored in open containers, waste often dumped just outside the walls. To modern eyes, such a place might seem like a paradise for microbes. But at the time, people had no concept of germs. Disease was mysterious, sometimes blamed on bad air, or curses, or divine punishment. The true cause remained invisible. And then, in the mid-1300s, one of the most devastating pandemics in human history began to spread. It would later be known as the Black Death. The Black Death was caused by a bacterium called Yersinia pestis. It spread primarily through fleas that lived on rats. And during the 14th century, trade networks connected cities across Asia, the Middle East, and Europe. Merchant ships carried goods across oceans. Caravans crossed deserts and mountains. Unfortunately, they also carried infected rats. And once the disease entered a crowded city, it spread with terrifying speed. People developed fever, painful swollen lymph nodes, dark patches appearing on the skin. In many cases, death followed within days. The pandemic moved across continents like a silent storm. By the time it subsided, an estimated 1/3 of Europe's population had died. Entire villages vanished. Fields were abandoned. Cities fell quiet. Historians estimate that worldwide, the Black Death may have killed 50 million people or more. To understand the scale of that disaster, imagine if 1 out of every 3 people you know suddenly disappeared. Friends, neighbors, family members, entire communities altered forever. And yet, even this catastrophic pandemic did not wipe out humanity. In fact, it unintentionally reshaped society in ways that changed the course of history. With so many people gone, labor became scarce. Workers gained more bargaining power. Feudal systems began to weaken. New economic structures emerged. It was a tragic transformation, but one that ultimately helped accelerate social and technological change. Human history, once again moving forward through adversity. The Black Death was not the only time disease reshaped civilization. Centuries later, another devastating pandemic appeared. This time, during the early 20th century. In 1918, near the end of the First World War, a new strain of influenza began spreading across the globe. Today we call it the Spanish flu. Unlike many flu viruses, this one behaved in unusual ways. It spread extremely quickly, and it struck young, healthy adults particularly hard. Within months, the virus had reached nearly every corner of the planet. Cities closed schools, hospitals overflowed. Entire communities struggled to cope with the number of sick patients. By the time the pandemic ended in 1920, it is estimated that 50 to 100 million people had died worldwide, more than the number killed during the entire First World War. It was one of the deadliest disease outbreaks in recorded history. Yet even this global catastrophe did not bring humanity to extinction. Why? Because humans had begun developing something powerful: science. By the 20th century, scientists had finally identified microbes as the cause of many diseases. Medical research expanded rapidly. Vaccines were developed. Public health systems improved sanitation and hygiene. Hospitals became more capable of treating patients. These innovations dramatically reduced the impact of many infectious diseases. But the battle between humans and pathogens never truly ends. Viruses evolve. Bacteria mutate. New diseases occasionally emerge. And sometimes, the world receives a reminder that even modern societies remain vulnerable. In recent years, the world experienced another global pandemic. The virus responsible spread rapidly across continents. Air travel connected distant cities within hours. News traveled instantly. Governments implemented measures to slow the spread. Scientists worked around the clock to develop vaccines. It was a difficult period for many people, but it also demonstrated something remarkable about modern civilization: humanity's ability to cooperate on a global scale. Researchers from many countries shared data. Medical teams worked tirelessly. Vaccines were developed faster than ever before in history. Within a relatively short time, science helped bring the crisis under control. Looking back across thousands of years, we can see a pattern. Human survival has never been guaranteed. From ancient volcanic winters to ice ages to deadly pandemics, our species has faced countless challenges. Yet one characteristic repeatedly appears in these survival stories: adaptation. When the environment changes, humans innovate. When diseases spread, humans study them. When disasters strike, people share knowledge and develop solutions. It's not perfect. Mistakes happen. But the long arc of human history shows an extraordinary capacity for learning. Still, even with modern science, the possibility of global catastrophe has not disappeared. In fact, some of the greatest extinction risks humanity faces today may come from technologies we ourselves have created. Powerful tools capable of shaping the future of our species, for better or for worse. In the next chapter of our story, we'll explore one of the most dramatic moments of the 20th century. A time when the survival of human civilization may have depended on a single decision. A moment during the Cold War, when the world came dangerously close to nuclear conflict. A conflict powerful enough to threaten the survival of humanity itself, and the fate of billions may have rested in the hands of just one person. The story continues. Up until now, most of the extinction threats we've explored came from nature: volcanoes, ice ages, pandemics. For millions of years, the forces that nearly erased humanity were outside our control. But during the 20th century, something extraordinary happened. For the first time in Earth's history, a species developed the power to destroy itself. And that power arrived in the form of a new kind of weapon: the nuclear bomb. The story begins in 1945, at the end of the Second World War. Scientists had discovered that the energy locked inside atoms could be released in an enormous explosion. When the first nuclear weapons were used in war, the world witnessed something terrifying. A single bomb could destroy an entire city. Buildings flattened, firestorms consuming neighborhoods, radiation spreading silently through the environment. But the most frightening realization came afterward. If a single bomb could do this, what would happen if hundreds were used, or thousands? In the decades that followed, two superpowers emerged as global rivals: the United States and the Soviet Union. Each nation began building large arsenals of nuclear weapons, missiles capable of traveling across continents in minutes, submarines carrying nuclear warheads beneath the oceans, bombers ready to launch devastating attacks. This tense period became known as the Cold War, and during those years, humanity lived under a strange shadow. The knowledge that a global nuclear war could begin at almost any moment. Scientists began studying what such a conflict might do to the planet. Their conclusions were sobering. Even if only a fraction of the world's nuclear weapons were used, the immediate destruction would be enormous. Cities would vanish. Millions of people would die within hours. But the long-term effects might be even more devastating, because massive fires from burning cities would send enormous clouds of soot into the atmosphere. These particles could block sunlight, cooling the planet, reducing crop production worldwide. Scientists call this scenario nuclear winter, a global climate disaster triggered not by volcanoes, but by human conflict. Food systems could collapse. Famine might spread across continents. Even regions far from the explosions could suffer severe consequences. In the worst-case scenarios, human civilization itself might collapse. And yet, there was one moment during the Cold War when such a catastrophe nearly began. A moment when the fate of the world may have rested on a single decision. The date was September 26, 1983. Deep inside a Soviet military facility, an officer named Stanislav Petrov was on duty. His job was simple in theory. Monitor early warning systems designed to detect incoming nuclear missiles. If the system detected an attack, he was required to report it immediately. Higher authorities would then decide whether to launch a nuclear response. But on that particular night, something unexpected happened. The computer system suddenly issued an alert. It reported that a missile had been launched from the United States. Then another. And another. Soon the system indicated that 5 nuclear missiles were heading toward the Soviet Union. According to protocol, this information should have been passed up the chain of command immediately. In a tense Cold War environment, such a warning might have triggered a retaliatory nuclear strike. But Stanislav Petrov hesitated. He studied the information carefully. Something didn't feel right. The system showed only a small number of missiles. If the United States were launching a real nuclear attack, it would likely involve hundreds of missiles, not just 5. Petrov also knew that the early warning system was relatively new. It could malfunction. And so, he made a decision. Instead of reporting the alert as a confirmed attack, he classified it as a false alarm. He waited. Minutes passed. Then more minutes. No explosions occurred. No missiles arrived. Later investigations revealed the cause of the error. Sunlight reflecting off high-altitude clouds had confused the satellite sensors. The system had misinterpreted the reflections as missile launches. If Petrov had followed protocol without question, the chain of events might have escalated dangerously. His quiet decision that night may have prevented a nuclear confrontation. One man, sitting in a control room, choosing caution over panic, and perhaps helping humanity avoid one of the greatest disasters imaginable. Stories like this remind us that the survival of our species sometimes depends on surprisingly small moments. A single decision, a single observation, a pause before acting. Throughout history, human extinction has often been narrowly avoided, sometimes through adaptation, sometimes through innovation, and occasionally through simple human judgment. The Cold War eventually ended. Nuclear arsenals were reduced. International agreements attempted to limit the spread of these weapons. But the existence of nuclear technology still raises important questions about the future. Human intelligence has given us extraordinary power. Power to explore space, power to cure diseases, power to reshape the planet, and power to potentially harm ourselves. Our survival may depend not only on scientific progress, but on wisdom. the ability to use powerful technologies responsibly as we continue this journey through humanity's fragile past. Consider how remarkable it is that we have reached this moment at all. From ancient bottlenecks of a few thousand individuals to billions of people living across the planet. From stone tools to spacecraft, the journey has been extraordinary. But the story of extinction risks is not finished, because in the next chapter, we'll explore threats that are still unfolding today. Asteroids, supervolcanoes, artificial intelligence, events that scientists continue to study as potential future risks to humanity. Some are extremely unlikely. Others deserve careful attention, and understanding them may help ensure that the long story of human survival continues. The story continues. For most of human history, the sky has felt peaceful, a vast dome above us, filled with stars that appear constant and eternal. But in reality, space is far from quiet. It is a dynamic place. Asteroids travel silently through the solar system. Comets sweep across long elliptical orbits. Fragments of ancient planetary debris moving through space at tens of thousands of kilometers per hour. And occasionally, one of these objects collides with Earth. When that happens, the results can be extraordinary. About 66 million years ago, long before humans existed, a massive asteroid struck the planet. It hit near what is now the Yucatan Peninsula in Mexico. The impact released an amount of energy billions of times greater than a nuclear bomb. The collision created a crater more than 180 kilometers wide, but the immediate explosion was only the beginning. Shock waves rippled across the planet. Gigantic earthquakes shook continents. Molten debris rained down through the atmosphere. Wildfires may have ignited across vast regions. Dust and soot filled the sky, blocking sunlight. Temperatures dropped. Plants struggled to grow. Food chains collapsed. Within a relatively short period of geological time, about 75% of all species on Earth disappeared. Among them, the dinosaurs. This event is known as the Cretaceous Paleogene extinction. It reminds us that Earth has experienced catastrophic impacts before, and although such events are rare, they are not impossible. Fortunately, the asteroid that ended the dinosaurs was enormous, roughly 10 kilometers wide. Impacts of that size occur extremely infrequently, perhaps once every tens of millions of years. But smaller asteroids strike Earth more often. Most burn up harmlessly in the atmosphere. Occasionally, however, one reaches the ground, and even relatively small impacts can cause significant damage. One famous example occurred in 1908 in a remote region of Siberia near the Tunguska River. Early in the morning, a brilliant flash streaked across the sky. Moments later, a powerful explosion shook the forest. Trees were flattened across an area of more than 2,000 square kilometers. That's an area roughly the size of a major city. Fortunately, the region was sparsely populated. Few people were injured. But scientists later concluded that the explosion was likely caused by a small asteroid or comet fragment exploding in the atmosphere. If the same event had occurred over a densely populated city, the consequences would have been far more devastating. Events like Tunguska are rare, but they remind us that Earth is not isolated from the rest of the solar system. Our planet travels through a cosmic environment filled with moving objects. Fortunately, modern science has given us tools our ancestors never had. Astronomers now track thousands of near-Earth asteroids. Powerful telescopes scan the skies. Computers calculate orbital paths years or decades into the future. Most of the large asteroids capable of causing global disasters have already been identified, and none are currently predicted to collide with Earth anytime soon. But detection is only part of the story. Scientists are also developing ways to deflect asteroids if one were ever found on a dangerous trajectory. In 2022, a remarkable experiment took place. A spacecraft deliberately collided with a small asteroid. The mission was called DART, the Double Asteroid Redirection Test. The goal was simple: see whether a spacecraft impact could slightly change an asteroid's orbit. The results were encouraging. The collision successfully altered the asteroid's path. Not dramatically, but enough to demonstrate that humans might one day redirect a dangerous object away from Earth. For the first time in history, our species tested a method for defending the entire planet from a natural cosmic threat. It's a fascinating moment in human history. For millions of years, life on Earth had no protection against asteroid impacts. Species simply lived with the risk. Some survived, others did not. But now, one species is developing the ability to intervene, to observe the sky, predict potential collisions, and possibly prevent them. A quiet but extraordinary shift. Human intelligence beginning to act as a planetary defense system. Of course, asteroids are not the only cosmic hazards. Occasionally, astronomers consider another dramatic possibility: a nearby gamma-ray burst. Gamma-ray bursts are among the most powerful explosions in the universe. They occur when massive stars collapse or when neutron stars collide. The bursts release intense beams of high-energy radiation. If such a beam were directed at Earth from relatively close range, it could potentially damage the ozone layer, allowing harmful ultraviolet radiation to reach the surface. Some scientists have speculated that events like this might have contributed to ancient extinction events. However, the probability of a gamma-ray burst occurring close enough to harm Earth is extremely low. Fortunately, the universe is vast. Most such events happen millions or billions of light years away. Still, the possibility reminds us that our planet exists within a larger cosmic environment, and occasionally, that environment can influence life here. But as we explore these cosmic risks, it's important to keep perspective. Humanity has survived countless natural dangers over hundreds of thousands of years, from volcanic winters to ice ages to pandemics. Asteroid impacts are another part of that long list of potential challenges. And for the first time, our species has the knowledge to monitor them, to prepare, perhaps even to prevent disaster. As you drift deeper into this quiet reflection on humanity's fragile history, consider how extraordinary it is that a species, once reduced to a few thousand individuals, now builds telescopes that scan the cosmos, from stone tools in ancient savannas to spacecraft protecting the planet. The journey has been remarkable, but our story with extinction risks is far from finished. Because in the next chapter, we'll explore one of the most powerful natural forces still hidden beneath Earth's surface, a force capable of reshaping climates, darkening skies, and challenging civilization itself. Supervolcanoes. Massive eruptions that occur only rarely, but when they do, their effects can echo across the entire planet. The story continues. When we think about volcanoes, we often imagine dramatic eruptions, rivers of lava flowing down mountains, ash clouds rising high into the sky. But most volcanoes on Earth, even the famous ones, are relatively small in geological terms. They affect local regions, perhaps a country, sometimes a few neighboring nations. Yet hidden beneath certain parts of our planet, there exist volcanic systems so vast that their eruptions could influence the entire world. These are known as supervolcanoes, and although they erupt very rarely, when they do, their effects can be felt across the globe. A typical volcanic eruption releases lava and ash from a mountain-shaped cone, but a supervolcano behaves differently. Instead of forming a tall peak, it often creates a massive underground chamber filled with molten rock. This chamber can stretch for dozens of kilometers beneath the surface. When pressure builds inside this enormous reservoir, the ground above it may collapse inward, creating a huge depression known as a caldera. Some of these calderas are so large, they can be seen clearly from space, and the eruptions that formed them were among the most powerful events in Earth's history. One of the most famous supervolcanoes lies beneath a beautiful national park in the United States. The landscape is filled with forests, lakes, and steaming geysers. Tourists travel from around the world to see it. This place is Yellowstone. Beneath Yellowstone lies a massive volcanic system that has erupted several times over the past few million years. The largest known eruption occurred about 2.1 million years ago. It released enormous amounts of ash and volcanic material into the atmosphere. Ash from that eruption spread across large portions of North America, and the explosion itself would have been thousands of times more powerful than the eruption of Mount St. Helens in 1980. Later eruptions occurred around 1.3 million years ago, and again roughly 640,000 years ago. Each event reshaped the surrounding landscape. Fortunately, such eruptions are extremely rare, and scientists carefully monitor Yellowstone today using seismographs, GPS measurements, and satellite observations. At the moment, there is no sign that a major eruption is imminent. Still, the existence of supervolcanoes reminds us that enormous geological forces continue to operate beneath Earth's surface. Another supervolcanic eruption occurred around 74,000 years ago. You may remember it from earlier in our story. The eruption of Mount Toba in what is now Indonesia. Toba's explosion was one of the largest volcanic events of the past 2 million years. The eruption blasted enormous quantities of ash high into the atmosphere. Some scientists believe the ash cloud may have partially blocked sunlight for years. This could have cooled the planet temporarily, a phenomenon known as a volcanic winter. During such events, fine particles in the atmosphere reflect sunlight back into space. Temperatures drop, growing seasons shorten, and ecosystems struggle to adapt. It's similar in some ways to the idea of nuclear winter we discussed earlier. Except this time, the source of the climate disruption is geological rather than human. Some researchers once proposed that the Toba eruption nearly wiped out early human populations. Although that theory remains debated, it illustrates how powerful these eruptions can be. A single event, affecting climate across the entire planet. If a large supervolcano erupted today, the effects would likely extend far beyond the immediate region. Nearby areas could experience heavy ashfall. Ash can collapse roofs, damage crops, disrupt transportation. Air travel in particular is extremely sensitive to volcanic ash. Even a relatively small eruption can ground aircraft across large regions. But the most significant impact might occur in the atmosphere. If enough volcanic particles reach high altitudes, they can spread globally, reducing sunlight slightly, cooling temperatures, and potentially affecting agriculture for several years. However, it's important to remember that such events are very rare. Supervolcano eruptions typically occur hundreds of thousands of years apart, and scientists are constantly improving their ability to monitor volcanic systems, ground movement, gas emissions, seismic activity. All provide clues about what is happening underground. If major changes occur, scientists are likely to detect them long before a large eruption takes place. Interestingly, supervolcanoes also remind us of something fascinating about Earth itself. Our planet is not static. The surface we walk on feels solid and permanent. But beneath it, enormous forces are constantly reshaping the world. Continents slowly drift across the globe. Mountains rise and erode. Magma circulates deep within the mantle. Over millions of years, These processes transform the planet. Life evolves, species appear and disappear, and occasionally, large geological events reshape the course of biological history. Despite these powerful natural forces, humanity has shown a remarkable ability to adapt. Agriculture spreads across climates. Technology allows food to be transported across continents. Scientific research improves our understanding of natural hazards. If a major volcanic eruption occurred today, it would certainly be challenging. But modern civilization possesses tools that ancient humans never had. Global communication, scientific forecasting, international cooperation. All of these increase our resilience. Still, the existence of supervolcanoes offers a quiet reminder of something humbling. Human civilization exists within a much larger planetary system, a system shaped by geological and cosmic forces far older than our species. Understanding these forces helps us prepare, but it also invites a sense of wonder. The world we inhabit is dynamic, complex, and sometimes unpredictable. As you continue drifting through this calm exploration of humanity's fragile journey, consider how many different forces have influenced our survival. Volcanoes beneath the earth, asteroids from space, climate systems spanning oceans and continents, invisible microbes, human technology. Each chapter reveals another piece of the story. But one of the most intriguing questions remains ahead, because in the next part of our journey, we'll explore a new kind of risk, one that does not come from nature alone, but from the rapidly advancing technologies created by human intelligence, artificial intelligence, biotechnology, and the surprising ways innovation might shape the future of our species. Some scientists believe these technologies could solve many of humanity's greatest challenges. Others warn they could introduce entirely new risks. Understanding them may be one of the most important tasks of the 21st century. The story continues. About 74,000 years ago, something happened on Earth so violent, so enormous, that if it had gone slightly differently, you would not be listening to this right now. Not because humans hadn't evolved yet, but because almost all of them nearly died. Scientists believe that during this time, the total number of humans on Earth may have dropped to just a few thousand individuals. Imagine that. Today there are 8 billion people on this planet. But once, our entire species may have been reduced to a population smaller than a modern town. And the cause of that catastrophe was not an asteroid, not a comet, not a pandemic. It was something far more terrifying, a supervolcano, a single volcanic eruption so powerful that it changed the global climate, darkened the skies, and may have pushed humanity to the edge of extinction. And it happened at a place called Lake Toba. But here's the strange part. Despite the scale of this disaster, scientists still argue today about how close humanity actually came to disappearing forever. Some believe Toba nearly wiped us out. Others believe we survived it with surprising resilience. So what really happened? Let's rewind the clock. The day Earth exploded. Lake Toba sits on the island of Sumatra in Indonesia. Today it looks peaceful. A long blue lake surrounded by green hills. But underneath that lake lies one of the largest volcanic craters on Earth. Because 74,000 years ago, that entire region blew apart in a massive eruption. Not a normal eruption, a super eruption. To understand the scale of this event, let's compare it with something familiar. The eruption of Mount St. Helens in 1980 was considered enormous. It released about 1 cubic kilometer of volcanic material. Toba? Toba released roughly 2,800 cubic kilometers. That's almost 3,000 times larger. If Mount St. Helens was a firecracker, Toba was a planetary bomb. Ash blasted 40 kilometers into the atmosphere. Volcanic material spread across millions of square kilometers. Ash from the eruption has been found as far away as India. Imagine waking up thousands of kilometers away and watching gray snow fall from the sky. But the ash was only the beginning of the problem. The real danger came from something invisible. The sky turned against us. When supervolcanoes erupt, they release enormous amounts of sulfur dioxide gas. High in the atmosphere, this gas forms sulfate aerosols, tiny particles that reflect sunlight. Think of them like a giant mirror around the planet. And suddenly, less sunlight reaches Earth. Temperatures drop. Seasons shift. Rain patterns collapse. Scientists call this effect volcanic winter. And after Toba erupted, the volcanic winter may have lasted years, or even decades. Some climate models suggest global temperatures may have dropped by 3 to 5 degrees Celsius. That might not sound dramatic, but globally, that is massive. During the last ice age, the difference between modern temperatures and peak glaciation was only about 5 to 6 degrees. So a sudden drop of several degrees could trigger ecological chaos. Forests die, grasslands shrink, animals starve, food chains collapse, and humans struggle to survive. But here's where the mystery deepens. Because if the disaster was that severe, why didn't humans disappear? The genetic bottleneck mystery. In the 1990s, geneticists discovered something strange while studying human DNA. Compared to other species, humans have very low genetic diversity. That means if you compare two random humans anywhere on Earth, their DNA is remarkably similar. Much more similar than chimpanzees living in the same forest. This puzzled scientists. Because large populations usually produce large genetic variation, but humans looked like a species that had once been severely reduced in numbers. A genetic bottleneck. Think of a bottle filled with colored marbles. Red, blue, yellow, green. If you suddenly pour most of them away, only a handful remain. Those few marbles determine the colors of every future generation. That's a bottleneck. And some researchers proposed a dramatic theory. They suggested that after the Toba eruption, the human population might have fallen to as few as 1,000 to 10,000 individuals worldwide. That's not a civilization. That's barely a species. But could one eruption really do that? Surviving the apocalypse. Let's imagine life during the Toba disaster. Ash clouds darken the sky. Sunlight weakens. Temperatures fall. Crops, if early humans had any esperanza, would fail. Wild plants would struggle. Animals migrate or die. Food becomes scarce. In many regions, survival would have become extremely difficult. But humans had one powerful advantage: adaptability. Unlike most animals, humans are incredibly flexible. We can live in deserts, in forests, in icy tundra. We can hunt, fish, gather, invent tools. And perhaps most importantly, we cooperate. Small groups of humans could move into regions where the effects were less severe. Coastal environments, tropical refuges, river valleys, places where food remained available. These pockets of survivors may have carried humanity through the catastrophe. And recent discoveries suggest something even more fascinating, because new archaeological evidence hints that humans might not have been as devastated as once believed. The debate among scientists. In southern India, archaeologists discovered stone tools buried in layers of ash from the Toba eruption. But here's the surprising part. The tools above and below the ash layer look nearly identical. That means humans were living there before the eruption, and they were still living there after it. In other words, at least some human population survived locally without disappearing. This challenges the idea that Toba nearly wiped us out. Instead, some scientists now believe the eruption was devastating, but not globally catastrophic for humans. The truth may lie somewhere in between. Some regions may have suffered massive population collapse. Others may have remained relatively stable. But either way, the event reminds us of something important. Human survival has never been guaranteed. Our species has walked along the edge of extinction more than once. And Toba isn't the only volcanic threat hiding on Earth today. Because right now, several supervolcanoes still exist, sleeping, waiting. The supervolcano is still alive today. There are around 20 known supervolcanoes on Earth. Most of them erupt only once every hundreds of thousands of years. But when they do, the effects are global. The most famous example sits beneath Yellowstone National Park in the United States. Yellowstone isn't just a beautiful park. It is actually a massive volcanic system. A giant magma chamber sits beneath the ground. And 3 times in the past 2 million years, Yellowstone has produced super eruptions. The last one happened about 640,000 years ago. Now, before panic sets in, scientists say there is no sign Yellowstone is about to erupt anytime soon. But the existence of supervolcanoes reminds us that Earth is not a quiet planet. It is alive, dynamic, unpredictable. And when we step back and look at the full story of Earth's history, we realize something astonishing. Humanity has survived asteroids, ice ages, volcanic winters, and cosmic radiation storms. But one question still remains. Which event came closest to wiping us out completely? And the answer might surprise you, because the greatest extinction threat in human history may not have come from space or volcanoes, but from something much smaller, something invisible, something that still exists today. In the next part, we're going to explore the terrifying possibility that disease, not cosmic disaster, may have been one of the greatest extinction threats humanity has ever faced, and how a microscopic organism could potentially reshape the future of our entire species. Let's continue. For most of human history, the greatest threat to our survival was not an asteroid, not a volcano, and not even climate change. It was something far smaller, something invisible, a single microscopic organism, a virus, a bacterium, a parasite. Tiny forms of life that we cannot see with our eyes, yet capable of reshaping civilizations. Because long before modern medicine, long before antibiotics, long before vaccines, a disease could move across continents like wildfire. And sometimes, it didn't just kill thousands, it killed tens of millions. But here's the unsettling thought. If just a few events in history had unfolded slightly differently, those same diseases might have pushed humanity dangerously close to extinction. To understand why, we need to step back and look at one of the most devastating biological disasters in human history. The Black Death. In the year 1347, strange ships began arriving in the ports of Europe. They came from the east, sailing across the Mediterranean. At first, everything seemed normal, but soon the sailors began to fall sick. Then the dock workers, then the merchants. Within days, entire neighborhoods were filled with people suffering from a mysterious illness. It began with fever and exhaustion. Then painful swellings appeared under the arms and around the neck, dark swollen lumps known as buboes. Soon after came chills, vomiting, and unbearable weakness, and then death. Sometimes within 3 days, sometimes within 24 hours. People had never seen anything like it. Doctors didn't understand what caused it. Priests believed it was divine punishment. Some towns thought poisoned air was responsible. Others blamed outsiders, foreigners, or supernatural forces. But none of these explanations could stop what was coming. Because the disease spreading through Europe was Yersinia pestis, the bacterium responsible for the bubonic plague. And it was about to change the course of human history. Over the next few years, the Black Death swept across Europe, the Middle East, and parts of Asia. City after city collapsed under the weight of the epidemic. In some villages, every single resident died. In crowded medieval towns, bodies piled up faster than they could be buried. Mass graves became common. Entire streets were abandoned. Travelers described landscapes where farms were empty, houses silent, and fields left unharvested. Historians estimate that the Black Death killed between 75 and 200 million people. In Europe alone, it wiped out about 1/3 of the population. Imagine that happening today. 1 out of every 3 people gone within a few years. The social impact was enormous. Economies collapsed. Labor shortages reshaped society. Feudal systems weakened. Entire political structures shifted. But the most terrifying part is this. The Black Death was not even the most contagious disease humanity has faced. Plague spreads mainly through fleas carried by rats. It is deadly, but its transmission has limits. Other diseases spread far more easily, which raises an unsettling question. What happens when a disease is both extremely contagious and highly lethal? To see how dangerous that combination can be, we need to move forward several centuries, to the year 1918. The world was already exhausted by war. World War I had devastated Europe. Millions of soldiers were living in cramped trenches and crowded camps. Troops were constantly moving between continents, and these conditions created the perfect environment for something unexpected: a virus. What became known as the Spanish flu began spreading quietly among soldiers. At first, it seemed like a normal influenza outbreak. People developed fever, cough, and fatigue. Most recovered. But then something strange happened. A second wave appeared, and this version of the virus was far more deadly. Healthy young adults suddenly collapsed with severe lung infections. Some victims turned blue from lack of oxygen. Others drowned in fluid filling their lungs. Doctors were overwhelmed. Hospitals ran out of beds. In some cities, the number of dead was so large that coffins became scarce. Unlike most flu outbreaks, which primarily affect the elderly and the very young, the Spanish flu attacked people in the prime of life. Soldiers, workers, parents. Within just 2 years, the pandemic infected roughly 1/3 of the global population, and it killed an estimated 50 million people. Some estimates suggest the real number may have been even higher. What made the Spanish flu especially frightening was its speed. Modern air travel didn't exist yet. And still, the virus reached nearly every corner of the planet. Imagine the same virus spreading in today's world of international flights and megacities. Fortunately, most influenza viruses have a mortality rate far below 1%. But the Spanish flu was far more dangerous. In some regions, mortality rates reach 2 to 5%. That may not sound extreme at first, but when billions of people are exposed, those numbers become staggering. Now consider something even more troubling. Many diseases throughout history have had much higher fatality rates. For example, the Ebola virus can kill up to 50% of those infected. Other pathogens, like certain strains of avian influenza, have mortality rates exceeding 30% in documented cases. Thankfully, these viruses do not spread easily between humans. But scientists often ask a difficult question. What would happen if a virus combined 3 characteristics at once? Extremely contagious, long incubation period, high fatality rate. In other words, a pathogen that spreads silently before symptoms appear, travels easily between people, and kills a large percentage of those infected. History suggests that such a disease could cause devastation on a scale humanity has never experienced. And yet, there is also a reason for cautious optimism, because humanity today is not the same species it was centuries ago. We have global disease surveillance systems, medical research laboratories, rapid genetic sequencing, vaccines that can be developed in record time. The COVID-19 pandemic demonstrated both our vulnerabilities and our strengths. Within weeks of the virus being identified, scientists had mapped its genome. Within a year, multiple vaccines were being distributed worldwide. That kind of scientific response would have been unimaginable in earlier centuries. But even with modern technology, pandemics remain one of the most serious risks to human civilization. Nature continues to evolve new viruses. Animal reservoirs harbor countless unknown pathogens, and global travel allows diseases to move across continents faster than ever before. The story of disease reminds us of something profound. Humanity's greatest threats are not always the most dramatic. They are not always visible in the sky or rumbling beneath the ground. Sometimes they are microscopic, silent, waiting for the right conditions. And yet, despite all of these dangers, humanity has survived every pandemic so far. We adapted, we learned, we developed medicine, and we built systems to protect ourselves. But the story of near-extinction events is far from over, because the next threat we are about to explore did not come from disease, or volcanoes, or even space. It came from something even more powerful: the changing climate of our own planet. And at several points in Earth's history, sudden climate shifts nearly erased entire species, including possibly our own ancestors. In the next part, we'll explore how rapid climate change has shaped human evolution, and how close those environmental shifts may have brought us to the edge of extinction. Long before cities, long before agriculture, long before humans built civilizations, our ancestors lived at the mercy of the environment. They had no technology to control nature, no global supply chains, no electricity, no modern shelters. If the climate changed suddenly, they could not stop it. They could only adapt or die. And several times in Earth's history, climate shifts were so dramatic that entire ecosystems collapsed. Animals vanished, vegetation disappeared, rivers dried up, and early humans were forced to fight for survival in a world that was suddenly becoming hostile. One of the most fascinating examples happened roughly 900,000 years ago. At that time, our ancient human relatives were already spreading across parts of Africa and Eurasia. They used simple stone tools. They hunted small animals. They gathered fruits and plants. Life was difficult but stable enough for small populations to survive. Then the climate changed, and it changed fast. Scientists studying ancient sediments, fossils, and climate records discovered evidence of a severe environmental shift during this period. Temperatures dropped dramatically. Ice sheets expanded across the northern hemisphere. Rainfall patterns changed. Large regions that were once fertile grasslands turned into cold, dry landscapes. For early human populations, this would have been catastrophic. Food sources disappeared. Animals migrated away. Water became scarce. Entire habitats collapsed. A recent genetic study published in 2023 suggested something astonishing. During this climate crisis, the global human population may have fallen to just around 1,200 breeding individuals. Think about that number for a moment. Not 1,200 people in one region, but roughly 1,200 individuals capable of producing the next generation across the entire planet. To put that into perspective, a small modern village can easily have more people than that. And yet those few survivors may have carried the genetic legacy of all future humans. For approximately 117,000 years, humanity may have remained at extremely low population levels. That is an incredibly long time. Entire species often disappear during crises that last only a few thousand years. But somehow, our ancestors endured. How did they survive? Part of the answer lies in one of humanity's greatest evolutionary advantages: flexibility. Many animals depend on very specific environments. Pandas rely on bamboo forests. Koalas depend on eucalyptus trees. Polar bears require Arctic ice. But humans are different. Even our early ancestors were capable of living in many types of environments. savannas, woodlands, river valleys, coastal regions. If one ecosystem collapsed, small groups could migrate to another. Migration became a survival strategy. Early humans followed animals, water sources, and seasonal vegetation. Over generations, these movements slowly spread human populations across continents. But migration alone was not enough. Another critical factor was cooperation. Humans are social creatures. We share food, we protect each other, we raise children collectively. During harsh environmental conditions, these social behaviors can make the difference between extinction and survival. A lone individual struggling in a harsh landscape might not survive long. But a group that shares knowledge, tools, and resources has a far greater chance. Imagine a small group of early humans during a prolonged drought. Food is scarce. Animals are difficult to hunt. Plants are failing. In such a situation, cooperation becomes essential. Some members search for edible plants. Others track animals. Some protect the group. Others care for children. Knowledge spreads within the group. Which plants are safe to eat? Where hidden water sources can be found? Which migration routes animals follow during dry seasons? This collective intelligence becomes a powerful survival tool. Over time, groups that cooperated effectively were more likely to survive environmental crises, and those behaviors slowly became part of human culture and evolution. But climate threats did not disappear after that ancient bottleneck. In fact, our species faced another enormous environmental challenge much later, during the last ice age. Around 20,000 years ago, massive glaciers covered much of North America and northern Europe. Some ice sheets were more than 3 kilometers thick. Imagine walls of ice taller than the tallest mountains in many regions today. Global temperatures were dramatically lower. Sea levels were about 120 meters lower than today. Large areas of the planet were cold, dry, and difficult to inhabit. Yet even during this harsh period, humans managed to expand into new territories. Groups crossed land bridges that no longer exist today. One of the most famous examples is the Bering Land Bridge. During the Ice Age, lower sea levels exposed a massive stretch of land connecting Siberia and Alaska. This allowed humans and animals to move between Asia and North America. Over generations, early humans migrated across this frozen corridor, eventually spreading throughout the Americas. What makes this story remarkable is that it happened during one of the coldest periods in recent geological history. Instead of retreating, humans explored. Instead of collapsing, they adapted. New tools appeared. Clothing made from animal hides helped protect against cold temperatures. Shelters improved. Hunting techniques became more sophisticated. These innovations allowed humans to survive in environments that would have been impossible for earlier ancestors. The Ice Age eventually ended around 11,700 years ago, marking the beginning of the relatively stable climate period we live in today. This period is known as the Holocene. During the Holocene, temperatures stabilized. Agriculture emerged. Cities formed. Civilizations began to rise. But the deeper lesson from human history is this: our species has repeatedly survived extreme environmental challenges. Climate shifts that reshaped continents, volcanic winters that darkened the skies, pandemics that wiped out entire populations. And yet humanity endured. Not because we are the strongest species, not because we are the fastest, but because we adapt, we innovate, we cooperate. Still, the story of near-extinction events raises an intriguing question. What if the greatest danger to humanity is not something from the past, but something that could happen in the future? Because there is one cosmic threat that scientists watch very carefully. A threat capable of causing destruction on a planetary scale. A threat that has already wiped out countless species throughout Earth's history. Asteroids. In the next part, we will explore how impacts from space have repeatedly reshaped life on Earth, and how close our planet may come to facing such a catastrophe again. Around 66 million years ago, Earth looked very different from the world we know today. There were no cities, no humans, no birds singing in city parks. Instead, the planet was dominated by creatures that had ruled for more than 160 million years. Dinosaurs. They walked across forests, deserts, and coastal plains. Some were the size of chickens. Others were larger than a modern bus. For millions of years, these animals thrived. They survived volcanic eruptions. They survived climate fluctuations. They adapted again and again. It seemed like their reign might continue indefinitely. But then something arrived from space. And in a single moment, the balance of life on Earth changed forever. Somewhere in the outer region of the solar system, a giant asteroid had been orbiting the sun for millions of years. Roughly 10 to 12 kilometers wide, it was essentially a mountain of rock traveling through space. At some point, gravitational interactions nudged its orbit. Slowly, over millions of years, the asteroid's path shifted, until one day, its trajectory intersected with Earth. The asteroid entered our atmosphere at a speed of roughly 20 kilometers per second. That's about 70,000 kilometers per hour, faster than a rifle bullet. At that speed, the air in front of the asteroid compressed violently, creating extreme heat. The object itself began to glow like a blazing star. Anyone watching from the ground would have seen something terrifying. A brilliant fireball racing across the sky. But there would have been no time to react. Within seconds, the asteroid slammed into what is now the Yucatan Peninsula in Mexico. The collision released an amount of energy equivalent to billions of nuclear bombs. The impact instantly vaporized rock, water, and the asteroid itself. A massive crater more than 180 kilometers wide formed in the Earth's crust. Today, that crater is known as Chicxulub. The immediate effects were unimaginable. The impact generated a shock wave that traveled through the ground with the force of a massive earthquake. Some estimates suggest the quake may have reached a magnitude of 10 or higher. That is far stronger than any earthquake recorded in modern history. At the same time, trillions of tons of debris were blasted high into the atmosphere. Molten rock fragments rained back down across the planet. As they fell through the air, they heated the atmosphere dramatically. In many places, the sky may have glowed red as these fragments re-entered. Some scientists believe this process ignited global wildfires. Forests across continents may have caught fire almost simultaneously. But the most devastating effect came afterward. The enormous cloud of dust, ash, and vaporized material spread around the globe. Sunlight struggled to penetrate the thick layer of particles in the atmosphere. Temperatures began to drop. Photosynthesis slowed dramatically. Plants died, and when plants disappear, the entire food chain begins to collapse. Herbivores starve. Carnivores soon follow. Over the next months and years, ecosystems across the planet unraveled. This event triggered what scientists call the Cretaceous-Paleogene extinction, one of the 5 largest mass extinctions in Earth's history. About 75% of all species disappeared. The dinosaurs, which had dominated Earth for over 100 million years, vanished completely. But the extinction was not total. Some creatures survived: small mammals, certain birds, reptiles, amphibians, tiny organisms in the oceans. Life on Earth was battered but not erased. And in the quiet aftermath of this catastrophe, a new evolutionary chapter began. With dinosaurs gone, many ecological niches were suddenly empty. Small mammals that had once lived in the shadows began to diversify. They grew larger. They adapted to new environments. Some became fast runners. Others climbed trees. Some returned to the oceans. Over tens of millions of years, this radiation of mammals eventually produced primates. And much later, humans. In a strange way, our existence may be connected to that ancient cosmic collision. If the asteroid had missed Earth entirely, Dinosaurs might still dominate the planet today, and mammals might have remained small, hidden creatures. But the story of asteroid impacts did not end with the dinosaurs. Earth continues to share the solar system with countless rocks and debris. Some are tiny grains of dust that burn up harmlessly in the atmosphere. Others are larger asteroids capable of causing serious damage. Most of them orbit safely in the asteroid belt between Mars and Jupiter. But gravitational interactions occasionally send objects toward the inner solar system. Scientists track many of these objects today. They are called near-Earth objects, or NEOs. Astronomers use powerful telescopes to monitor their orbits and calculate potential impact risks. The good news is that extremely large impacts like the one that ended the dinosaurs are very rare. Events of that magnitude happen perhaps once every tens of millions of years. However, smaller impacts occur more frequently. In 1908, an object estimated to be around 50 to 60 meters wide exploded above the Tunguska region of Siberia. The explosion flattened roughly 2,000 square kilometers of forest. Trees were knocked down in every direction. If that same explosion had occurred above a major city, the destruction would have been catastrophic. More recently, in 2013, a much smaller asteroid exploded in the sky above Chelyabinsk, Russia. The shockwave shattered thousands of windows and injured over 1,000 people, mostly from flying glass. Fortunately, that asteroid was only about 20 meters wide. Events like these remind scientists that asteroid impacts are not just ancient history. They are part of the ongoing dynamics of our solar system. The difference today is that humanity now has the ability to detect many of these objects long before they arrive. Space agencies around the world monitor the skies constantly, and researchers are developing ways to potentially deflect dangerous asteroids. In 2022, NASA successfully tested a mission called DART, which deliberately crashed a spacecraft into a small asteroid to change its orbit slightly. It was the first real demonstration of planetary defense technology. For the first time in history, a species on Earth has begun developing tools to protect the planet from cosmic impacts. But even with these advances, the universe remains unpredictable. Asteroids, comets, and other cosmic hazards continue to travel through space. Most will never come near Earth, but the possibility always exists. The story of the dinosaur extinction reminds us of something important. Life on Earth has always been vulnerable to forces far beyond our control, yet it also shows something remarkable. Even after the most devastating catastrophes, life finds a way to continue. In the next part, we will explore a different kind of cosmic threat. Not a rock from space, but something far more mysterious. Powerful bursts of radiation from distant stars known as gamma-ray bursts. Events so energetic that, under the right circumstances, they could affect life across an entire planet. Imagine looking up at the night sky. Thousands of stars scattered across the darkness. Most of them calm, stable, shining gently across unimaginable distances. But hidden among those distant stars are some of the most violent events in the universe. Explosions so powerful that they briefly outshine entire galaxies. Events capable of releasing more energy in a few seconds than our sun will produce in its entire lifetime. These events are known as gamma-ray bursts. And if one occurred close enough to Earth and happened to aim directly at our planet, it could trigger a global catastrophe. To understand why scientists take this possibility seriously, we first need to understand what a gamma-ray burst actually is. Gamma rays are the most energetic form of light. They carry far more energy than visible light, X-rays, or ultraviolet radiation. On Earth, gamma rays are produced by radioactive materials and certain high-energy processes. But the gamma rays generated by cosmic explosions are on a completely different scale. A gamma-ray burst is essentially a focused beam of extremely intense radiation produced during some of the most dramatic events in the universe. there are two main types. The first occurs when two neutron stars collide. Neutron stars are the incredibly dense remnants left behind after massive stars explode as supernovae. Imagine squeezing a mass greater than our Sun into a sphere only about 20 kilometers across. The result is an object so dense that a single teaspoon of its material would weigh billions of tons. When two neutron stars orbit each other, they slowly spiral closer together. Eventually, they collide. The impact releases enormous energy, producing gravitational waves and a burst of gamma radiation that travels across space. The second type of gamma-ray burst occurs when a massive star collapses into a black hole. During this process, the star's core implodes. Jets of high-energy particles shoot outward along the star's rotational axis at nearly the speed of light. These jets produce powerful beams of gamma radiation that can travel for billions of light years. The key detail is this: gamma-ray bursts are not emitted equally in all directions. They are focused into narrow beams. Think of them like cosmic flashlights. If Earth happens to lie outside the beam, we might never notice the event. But if the beam points directly at us, the radiation could strike our planet with enormous intensity. Fortunately, most gamma-ray bursts occur extremely far away, often billions of light years from Earth. At those distances, they pose no danger. But astronomers sometimes ask an unsettling question. What would happen if a gamma-ray burst occurred relatively close to Earth? Close, in cosmic terms, might mean within a few thousand light years. If a powerful gamma-ray burst were aimed directly at our planet from that distance, the effects could be dramatic. The radiation itself would not necessarily kill life instantly. Earth's atmosphere provides some protection, but the burst could damage the ozone layer, which shields the surface from harmful ultraviolet radiation. Without sufficient ozone, sunlight reaching Earth would contain much higher levels of ultraviolet radiation. Plants would struggle to survive. Plankton in the oceans, which form the base of marine food chains, would be especially vulnerable. With plankton populations collapsing, entire ocean ecosystems could begin to unravel. Animals that rely on those food chains would suffer. Over time, this could trigger a cascading ecological crisis across the planet. Some scientists have even suggested that a gamma-ray burst might have contributed to one of Earth's ancient extinction events. Around 440 million years ago, during the Ordovician mass extinction, roughly 85% of marine species disappeared. The exact cause remains uncertain. Some researchers believe a nearby gamma-ray burst could potentially explain certain patterns seen in the fossil record. This idea remains speculative, but it illustrates how powerful these cosmic events can be. The good news is that the probability of a gamma-ray burst affecting Earth is extremely low. Astronomers have studied nearby stars that might eventually produce such explosions. Most of them are far enough away that they pose no realistic threat. However, there is one star system that occasionally appears in discussions about potential future gamma-ray bursts. It is called WR-104, located roughly 8,000 light-years away in the constellation Sagittarius. WR-104 is a massive binary star system that may one day explode as a supernova. Because of its orientation, some early studies suggested its rotational axis might point roughly in Earth's direction. If that were true, and if the star eventually produced a gamma-ray burst, the radiation beam could theoretically intersect our planet. However, more recent observations suggest the alignment may not be as direct as once thought. And even if it were, the distance is likely large enough that Earth would experience minimal effects. Still, events like this remind scientists how dynamic and unpredictable the universe can be. Stars are born. They evolve. They explode. Black holes collide. Neutron stars merge. And occasionally, the energy released in these processes travels across vast cosmic distances. Yet despite the immense power of these phenomena, life on Earth has persisted for billions of years. Our planet has survived asteroid impacts, supervolcano eruptions, ice ages, mass extinctions, and perhaps even cosmic radiation events. Each time, life adapted, species evolved, new ecosystems emerged. In many ways, the history of life on Earth is a story of resilience, but understanding these cosmic threats also reveals something remarkable about the present moment. For the first time in Earth's history, a species exists that can study these dangers before they happen. Humans can observe distant stars, detect radiation bursts across galaxies, track asteroids, model climate systems, and develop technologies that may one day help protect our planet. Knowledge does not eliminate every risk, but it gives us something our ancestors never had: awareness. And awareness is the first step toward preparation. Still, cosmic dangers are only part of the story, because the greatest extinction risks humanity has faced may not always come from space. Sometimes the most dangerous forces are the ones that originate here on Earth. In the next part, we will explore a different question. Not how the universe might threaten humanity, but how humanity might threaten itself. From nuclear weapons to environmental collapse, we will examine how the future of our species may depend on the choices we make in the centuries ahead. Throughout this series, we've explored many threats that nearly ended life on Earth. Asteroids from deep space, supervolcanoes powerful enough to darken the sky, pandemics capable of sweeping across continents, cosmic radiation from distant stars. All of these forces remind us that the universe can be a dangerous place. But there is another kind of threat that scientists discuss with increasing seriousness. A danger that does not come from space. It does not erupt from the Earth's crust, and it does not evolve inside microscopic organisms. It comes from us. For the first time in the history of life on this planet, a species has developed the power to dramatically reshape the entire world. Human civilization has created technology capable of transforming landscapes, altering ecosystems, and even changing the atmosphere itself. This power has brought extraordinary progress: modern medicine, global communication, scientific discovery. But it has also introduced new risks. Some scientists describe this moment as a turning point in Earth's history, a new geological era known as the Anthropocene, an age defined by human influence on the planet. One of the most serious concerns is nuclear weapons. In 1945, humanity entered the nuclear age. When the first atomic bombs were detonated, they demonstrated a level of destructive power unlike anything previously seen in warfare. The explosions over Hiroshima and Nagasaki revealed how much energy could be released from splitting the atom. In the decades that followed, nuclear technology advanced rapidly. Countries around the world developed larger and more powerful nuclear arsenals. Some modern thermonuclear weapons are hundreds of times more powerful than the bombs used during World War II. Today, thousands of nuclear warheads still exist across the globe. Many of them are capable of being launched within minutes. Scientists have studied what might happen if a large-scale nuclear conflict occurred. The immediate destruction from explosions would be catastrophic. Cities could be destroyed. Infrastructure would collapse. Millions of people could die within hours. But the long-term consequences might be even more severe. One of the most concerning possibilities is something called nuclear winter. When nuclear explosions ignite massive fires in urban areas, enormous amounts of smoke and soot rise into the atmosphere. These dark particles could spread around the planet, blocking sunlight. Just as volcanic eruptions can cool the earth by filling the atmosphere with aerosols, widespread firestorms could produce a similar effect. Global temperatures might drop dramatically. Growing seasons could shorten. Agriculture would suffer. Food production might collapse across many regions of the world. Even countries far from the conflict could experience severe shortages. In the worst scenarios, the global food supply could be disrupted for years. Another risk connected to human activity is environmental degradation. Human civilization has expanded rapidly over the past 2 centuries. Industrial development, agriculture, and urbanization have transformed vast areas of the planet. Forests have been cleared, rivers have been altered, wild ecosystems have been fragmented. Many species have disappeared as their habitats vanished. Scientists estimate that the current rate of species extinction is significantly higher than the natural background rate seen in the fossil record. Some researchers refer to this period as the beginning of a sixth mass extinction. Unlike previous mass extinctions triggered by asteroid impacts or massive volcanic eruptions, this one may be driven largely by human activity, habitat destruction, pollution, climate change, overfishing, invasive species. These pressures combine to reshape ecosystems around the world. However, the relationship between humans and the environment is complex. Human technology has caused many environmental challenges, but it also provides tools for solving them. Renewable energy technologies are expanding rapidly. Solar power, wind power, advanced battery systems. Scientists are developing new ways to reduce carbon emissions and restore ecosystems. Large conservation programs aim to protect forests, oceans, and biodiversity. The future of the planet may depend heavily on how humanity chooses to use its technological power. There is another emerging concern that scientists sometimes discuss: advanced technologies themselves, artificial intelligence, biotechnology, genetic engineering. These tools have enormous potential to improve human life. They could help cure diseases, improve agriculture, and expand scientific knowledge. But like many powerful technologies, they must be used carefully. Biological research, for example, allows scientists to study viruses and bacteria in great detail. This knowledge helps develop vaccines and treatments. But it also means that dangerous pathogens can be studied in laboratories. Most research facilities operate under strict safety standards. Still, experts emphasize the importance of responsible oversight as these technologies continue to advance. Despite these challenges, there is also a hopeful perspective. Human history shows that societies can learn from mistakes. Environmental awareness has grown dramatically in recent decades. International agreements have reduced certain pollutants that once threatened the ozone layer. Wildlife conservation programs have helped restore some endangered species. Global cooperation has achieved successes in disease control and environmental protection. Perhaps the most important difference between humanity and other species is our ability to reflect on our actions. We can study our impact on the planet, we can anticipate risks, and we can make choices that shape the future. The same intelligence that allowed humans to build cities, explore space, and map the human genome may also help guide civilization toward more sustainable paths. The story of human survival is not just a story of avoiding natural disasters. It is also a story of learning, adapting, and improving our understanding of the world. The question of whether humanity will face extinction is not only determined by cosmic events or geological forces. It is also influenced by the decisions we make. Our technology gives us unprecedented power, but it also gives us unprecedented responsibility. And that responsibility may define the next chapter of human history. In the final part of this series, we will step back and consider a larger question. After all the dangers humanity has faced, after all the near extinction events throughout Earth's history, how close did our species truly come to disappearing? And what does that tell us about the future of life on this remarkable planet? After exploring volcanic winters, asteroid impacts, ancient pandemics, cosmic radiation, and even the risk created by our own technology, a powerful question remains. How close did humanity truly come to disappearing? Was our survival always likely? Or were there moments in history when our entire species balanced on the edge of extinction? To answer that, scientists look at three different kinds of evidence: fossils, climate records, and perhaps most importantly, our DNA. Our genetic code is more than just a blueprint for building the human body. It is also a historical archive. Hidden inside every cell of our bodies is a record of our ancestors. When scientists compare human DNA from populations around the world, they notice something remarkable. Human beings are genetically very similar to one another, much more similar than many other species. Two chimpanzees living in the same forest can be more genetically different from each other than two humans living on opposite sides of the planet. At first, this puzzled scientists. A species with billions of individuals spread across continents would normally develop much greater genetic diversity, but humans do not. And the most likely explanation is that our species passed through one or more severe population bottlenecks, moments in history when the number of humans dropped dramatically. When populations shrink to very small numbers, genetic diversity shrinks with them. Future generations inherit only the genes carried by those few survivors. This idea led scientists to investigate some of the most difficult periods in Earth's environmental history. One of the strongest candidates for a human bottleneck is the climate crisis we discussed earlier, around 900,000 years ago. During this time, dramatic shifts in global climate may have reduced early human populations to extremely small numbers, possibly as few as a few thousand individuals. For comparison, some endangered animal species today have larger populations than that. Another potential bottleneck may have occurred after the Toba super eruption around 74,000 years ago. The enormous volcanic eruption may have caused a volcanic winter that disrupted ecosystems across much of the planet. While scientists continue to debate how severe the population decline was, some genetic studies suggest that human populations may have dropped to only several thousand individuals during this period. Imagine the fragility of our species at that time. No cities, no agriculture, no advanced tools, just small groups of hunter-gatherers scattered across vast landscapes. If a few of those groups had disappeared, human history might have unfolded very differently. But despite these challenges, humanity survived. And survival was not simply a matter of luck. Our ancestors possessed a combination of traits that helped them endure extreme circumstances. One of those traits was intelligence. Early humans developed tools that improved hunting and food gathering. Stone blades, spears, eventually bows and arrows. These innovations made it possible to hunt animals more efficiently and exploit a wider variety of food sources. Another key trait was communication. Language allowed humans to share knowledge across generations, information about migration routes, seasonal weather patterns, dangerous animals, edible plants. Instead of rediscovering survival strategies each generation, humans could build on accumulated knowledge. This gave our species a powerful advantage. Then there was cooperation. Many animals compete within their groups for survival. Humans cooperate extensively. Food sharing, child care, collective hunting, community defense. These behaviors allowed small human populations to survive conditions that might have destroyed more solitary species. But perhaps the most important trait was adaptability. Humans are not specialized for one specific environment. We can live in deserts, forests, mountains, and frozen tundra. Over thousands of years, human groups adapted to an extraordinary range of climates, from the Arctic Circle to tropical rainforests, from high mountain plateaus to coastal islands. Few species on Earth possess that level of environmental flexibility. Because of these abilities, humanity gradually recovered from the ancient bottlenecks that once threatened our survival. Population numbers slowly increased. Humans spread across continents. Cultures developed. Agriculture appeared around 12,000 years ago, allowing societies to support larger populations. Cities formed. Civilizations emerged. Technology advanced. Today, humanity numbers more than 8 billion people. That number is so large it is difficult to imagine. But when we look back at our past, we realize something extraordinary. Every person alive today may be descended from a relatively small number of ancient survivors. individuals who endured droughts, ice ages, volcanic winters, and countless other hardships. Their survival allowed every generation that followed to exist. In that sense, the story of humanity is a story of resilience. But it is also a story of probability. The universe contains countless dangers. Asteroids still pass through our solar system. Stars still explode in distant galaxies. Viruses still evolve. Climate systems still shift. The difference today is that humanity is no longer completely helpless in the face of these forces. We monitor the skies for near-Earth objects. We study climate systems. We track emerging diseases. We develop technologies that our ancestors could never have imagined. Yet even with all this knowledge, the future remains uncertain. Civilizations rise and fall. Environments change. New challenges emerge. The survival of our species will depend not only on scientific progress, but also on wisdom. How we manage our resources. How we cooperate globally. How we balance technological advancement with responsibility. The truth is that extinction is a natural part of life on Earth. More than 99% of all species that have ever lived are now extinct. From that perspective, the continued survival of humanity is not guaranteed. But history shows that our species possesses remarkable strengths: curiosity, creativity, collaboration, the ability to learn from the past and imagine the future. These qualities have carried us through countless challenges already, and they may determine whether humanity continues its journey for thousands or even millions of years to come. In the final part of this series, we will step back and reflect on the bigger picture. After everything we have explored, one final question remains. What does the story of humanity's near-extinction events reveal about our place in the universe, and the extraordinary accident that is our existence on this small blue planet? Imagine standing at the edge of a quiet ocean at night. The waves move slowly, the wind is soft. The sky above is filled with stars that have burned for billions of years. It feels calm, stable, permanent. But the truth is, the universe has never been calm. For nearly 4.5 billion years, Earth has lived through chaos that would sound like science fiction if it weren't real. Asteroids large enough to erase continents. Volcanoes that covered the planet in darkness. Ice ages that turned oceans into frozen deserts. And yet somehow, here we are. Not just alive, but conscious enough to ask how close we came to disappearing. That question may be one of the most important questions our species can ask. Because when we understand how fragile our survival has been, we begin to understand how precious it is and how easily it could still be lost. Let's step back for a moment and look at the big picture. Over Earth's history, scientists believe there have been 5 major mass extinctions. Each one reshaped life on the planet. Each one erased entire branches of evolution. Imagine a gigantic tree of life. Every species is a branch. Now imagine someone coming along with a chainsaw and cutting off half the tree. That has happened again, and again, and again. One extinction wiped out 90% of marine species. Another ended the reign of the dinosaurs. Another nearly erased complex life entirely. And through every one of those disasters, life barely held on. Sometimes survival came down to tiny, fragile populations hiding in isolated pockets of the planet. Small fish in deep oceans. Microbes trapped in underground ecosystems. Plants surviving near volcanic heat vents. Life didn't win because it was strong. Life won because it was adaptable. And eventually, that adaptability led to us. But here's the strange part. For almost all of Earth's history, humans didn't exist. If you compress the entire 4.5 billion year timeline of Earth into a single 24-hour day, humans appear in the last few seconds before midnight. That means everything that almost ended life happened long before we even arrived. Which raises a fascinating thought. Humanity didn't just survive extinction events. We survived the aftermath of them. The environments that followed were harsh, unstable, and unpredictable. But those conditions created something powerful. They forced evolution to experiment. New ecosystems formed. New predators evolved. New survival strategies appeared. Eventually, one lineage of primates began developing larger brains, stronger social bonds, and something extraordinary. Curiosity. Curiosity may be the most powerful survival trait humanity has. It pushed our ancestors to explore beyond the safety of forests. It pushed early humans to learn how to control fire. It pushed civilizations to study the stars, the oceans, and the hidden forces of nature. And today, that same curiosity allows us to look backward in time and reconstruct the disasters that almost erased life. We drill ice cores from Antarctica. We analyze ancient rock layers. We map asteroid craters and volcanic provinces. And from these clues, science reconstructs a story that spans billions of years. A story where survival was never guaranteed. But there is another whisper of science that often goes unnoticed. Most extinction events were caused by natural forces beyond the control of life itself. Asteroid impacts, massive volcanic eruptions, orbital changes affecting climate. But today, something new exists on Earth. A species powerful enough to reshape the planet intentionally or unintentionally. Humans. For the first time in Earth's history, one species understands extinction before it happens. We know about asteroid threats. We monitor climate systems. We study biodiversity loss. We even develop technology capable of deflecting dangerous asteroids. That means humanity may become the first species, not only shaped by extinction, but capable of preventing one. And that is a remarkable turning point in the history of life. Think about the irony for a moment. The same intelligence that allows us to create advanced technology also creates risks. Nuclear weapons, environmental damage, artificial systems we don't fully understand yet. Our power to change the world is enormous. But our wisdom must grow just as fast, because the future of life on Earth may increasingly depend on choices made by humans, not by asteroids, not by volcanoes, but by us. And yet, despite all these risks, there is reason for optimism. Humanity has already overcome incredible challenges. Global cooperation has eliminated deadly diseases in many regions. Scientists around the world share knowledge instantly. Space telescopes search for dangerous near-Earth asteroids. Climate research helps us understand our planet better than ever before. We are no longer just passengers on Earth. We are becoming caretakers of a living planet. And that responsibility may define the next chapter of our story. If Earth has taught us anything over billions of years, it's this. Life is fragile, but life is also astonishingly resilient. Even after the worst extinction events, life eventually returned. Forests regrew, oceans filled with new creatures. Evolution found new paths. The story of Earth is not just a story of destruction. It is a story of recovery. And perhaps the greatest question of the future is whether humanity will help that recovery or threaten it. Some scientists believe the long-term destiny of intelligent life is not to remain on one planet forever. Eventually, our species may explore and settle other worlds. Mars, moons of Jupiter and Saturn, even distant planets around other stars. If that happens, the survival of life from Earth could extend far beyond the single planet. The fragile chain of evolution that began billions of years ago in Earth's oceans could continue across the cosmos. And if that day comes, future generations may look back at our time as the moment when humanity first understood just how close life had come to extinction and chose to protect it. So the next time you look up at the night sky, remember something remarkable. Every living thing on Earth today is the descendant of survivors, creatures that endured unimaginable disasters, lineages that passed through narrow evolutionary bottlenecks again and again. The fact that you are here, listening to the story, means your ancestors survived every one of them. Asteroids, ice ages, volcanic winters, mass extinctions, all of it, against impossible odds. And now the responsibility of continuing that story belongs to us. If this journey through Earth's near extinction moments fascinated you, take a moment to like the video, subscribe to the channel, and share it with someone who loves science and big cosmic questions. Your support helps this channel continue exploring the quiet whispers of science that shape our understanding of the universe. And before you go, I'd love to hear your thoughts. Which extinction event surprised you the most? Do you think humanity will become a protector of life or its greatest risk? Leave a comment below and join the conversation. Because the story of Earth and the future of humanity is still being written.